The simple pendulum. If we experiment with a simple pendulum, like this, we could change the mass, the length, or the amplitude of the swing of the pendulum. If we change the mass and measure the time period, we find this. The period of a simple pendulum is independent of the mass. If we change the amplitude and measure the time period, we also find this. The period of a simple pendulum is independent of the amplitude. However, if we vary the length of the pendulum and plot a graph of the time period squared against the length, we get a straight line through the origin. So this shows us that the square of the period of a simple pendulum is directly proportional to the length. If we find the gradient, we find it equals 4 pi squared over the acceleration due to gravity g. So we can write that the time period t is equal to 2 pi root L over g, where L is the length of the pendulum. When finding the time period of a pendulum, make sure you time complete oscillations. That's from one side to the other and back again. That was one complete oscillation. Time at least 20 oscillations, then divide your figure by 20 to get the time for one, and then repeat this at least 3 times for each length to find an average. Use at least 6 lengths over as wide a range as is possible.